What is that line AB called?
Chord.
No. Chord goes from one point on the.
Oh, sector?
Sector area.
No.
It's a segment.
No.
Does it start with an S?
Secant. Yeah.
Seagull. What the heck?
Secant just goes through the circle. All right. B. We said that. I said that word quite a bit. You guys know what line DE is? Tangent. Tangent has a normal English meaning. You guys know what it means? Like if you get your teacher to start talking about something besides,
They go on a tangent.
they go on a tangent.
What's that?
C, BC is a radius. D, what is segment AD diameter? E, what is segment AB? Chord.
Oh, that's what one I thought we were looking at.
Well, A says line,
Oh.
line AD or AB. I guess I'm at the bottom. Number 2 is like the worksheets we just did yesterday. Number 3, how do I find? Should we go around the room? Let's see. We're supposed to find angle ADE. Does anybody want to volunteer? What's the measurement of angle ADE? No. ADE is where the tangent hits the radius or the diameter or whatever. When the radius hits the tangent, it always hits at a 90. At that point of tangency, it's always 90 degrees. See how it looks perfectly like a 90-degree angle? It is. So 3A is 90 degrees.
That's what I said.
I know.
Why did you say it was wrong?
I did not.
You did. You said no.
No, I was talking to Katie. I was talking to somebody else.
Sorry, I got angry.
B is angle BCD. Kyle, what do you think angle BCD would be? It's not a trick question. Yeah, it is 64. The central angle, BCD, is equal to the arc that it intercepts. So if the arc is 64, the angle is 64 degrees. All right, DAB. Angle DAB. Ava, how do we find angle? What kind of angle is DAB, Ava?
A big one.
If the vertex is on the circle, like what kind of angle is that? When the vertex is like right here. Inscribed. And what's the relationship between the inscribed angle and its arc? It's half. So it's 30. Yeah, 32 degrees. Gosh. Angle ABC. Yeah, that's a tricky one.
Where?
I was looking at 4A. If they would have drawn the picture a little bit different, that would have helped. I'm gonna help you guys for A. Okay, 4A says find angle ABC, and this is angle ABC right here. So, so the problem is, if they would have extended this, maybe it wouldn't have been quite as hard. C is supposed to be the center. Okay, remember earlier we said this, well, that's 64, this is 64. So what's this angle right here have to be?
65.
So what's this arc right here have to be?
65.
Okay, now, the question was, this angle over here. You guys see it? It's an inscribed angle, and it intercepts 64. Maybe I'll just leave it at
32.
that, since it's an even, or yeah, it's even.
Wait, how the frick? I don't know. I still don't know.
It's an inscribed angle, and has 64 as its
Oh,
arc.
that's arc. I got you.
All right, number 5. We didn't do any review on this lesson because I didn't think it was as hard, although there was a lot of Pythagorean theorem on it. Do you guys remember, do you guys see the picture for 5 through 9? You guys remember how they would like ask us to find the radius, and we'd have to draw in a radius like a pH, and draw in line pH, and then use Pythagorean theorem. So the tricks from this lesson were, if those chords FH and JL are the same length, then they're the same distance from the center. Or you can say it backwards. If they're the same distance from the center, they have to be the same length. That was kind of the main trick. Also, the radius, if it's perpendicular to the chord, it cuts it in half. So, kind of the things you might guess are true on those. So, FH is 30. Find HN.
15.
Yeah. So, HN only goes halfway across. So HN is 15. There's actually 2 questions. So this is Natalie's though. So if FH is 30, Natalie, what is JL going to be? Yeah. And yes, it is 30 also. It says in the directions PM and MN or PM and PN are equal. So that means they're the same distance from the center. But yeah. So there's 2 answers. NH is 15. JL is 30. Number 7. I probably should draw this. If JL is 32 and PN is 12, find PK. PK, Caleb, is a what in that circle? It's a radius. So this is kind of what I was talking about. They made us find the radius. What did they say again? JL is 32. So, if JL is 32, what would this guy right here be? Half that, right?
Yeah, half of that.
So, 16. What else did it say? PN is 12. If PN is 12, that just means this PM is 12. So, they're both 12s right there. Okay, now here was the trick. This is 90-degree angle, and this is also a radius. That was the trick. And why is that helpful? Because we have a right triangle here, and Caleb, how do we find the missing side in a right triangle? What's the relationship between 3 sides in a right triangle?
Like Pythagorean theorem.
Yes.
Yeah.
And do you remember how that went?
A squared plus B squared plus C squared.
Yes.
So 12 squared plus 16 squared equals C
I put R because it was radius E,
Okay.
but it doesn't matter what letter you use, just make it up.
Yep.
Oh man, that's 2, 4. I think it comes out nicely. 400. You guys know what the square root of 400 is? 20. I think that was the only question on that one. Nope, I lied. MK. All right. So we just said this is 20.
Yep.
Well, we said this was 20, but if the radius is 20 here, the radius is 20 here. So if this is, the whole red thing is 20, then how far must it be just from here to here? From here to here is 12,
Oh.
and the whole thing is 20, so what must this be? Yeah, 8. These two have to add up to 20.
Oh.
So it's 20 and
8.
8. Yeah, one was kind of tricky, wasn't it? I think I can do a whole worksheet on just that. Number 7.
9. You just did 7.
Number 9. Did I put? I didn't never label them.
Whoops.
I think I just didn't label. Okay. Number 9. Find Fn if JL equals blah 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 and FH equals blah blah blah. So Isaac, how are JL and FH related to each other?
They're like.
Are they
Kinda.
are they the same? Is
Yeah,
like
they're the same.
one of them twice as big? Yeah, they're the same. So all that JL and FH stuff is just equal to each other. It's just an algebra problem. X squared plus
Not solvable.
no, this one's not. That's okay. Yeah, that's right. All right. Any ideas, Isaac?
Plus 12.
Okay, let's start with what do we do about the x squareds? Well, normally when you solve an x squared problem, we did one of these in this chapter, you move everything to one side. Just like you move x's to one, like try to get x to one side. Normally on x squared problems, you move everything over and you set it equal to 0. But what happens when I minus x squared? Yeah. So that kind of gets rid of our quadratic equation problem. So it's just 8x minus 12 equals negative. So that makes it a lot more basic. So now what do I do?
Plus 5x. Plus 12.
How many times 13 go into 39?
3.
3. Is that the final answer? No, I don't think so. They ask for Fn. If you look at the picture, Fn is just half of FH. So if we plug 3 in to FH and then divide our answer by 2, that should do it. So I'm going to plug in 3. Actually, you should get the same answer on both of these, but if I plug in 3 right there, I get 3 squared minus 5 times 3 plus 27. I believe that's 11.
21.
That's a minus 15. Oh, I forgot to divide by 2 also. How'd you get 21? You're right, you're right. Okay, but I forgot to divide by 2, so it's 10 Okay, speaking of Pythagorean theorem, number 11. So, kind of talked about this on number 3, but what angle does QRT have to be? What angle is QRT?
QRT?
Yes, on number
Which
11.
one?
Number 11. Yes, number 11. Angle QRT. Or sorry, QRS. My bad.
A Q?
No. Right. A tangent that meets the radius, it's just like 3A. When the tangent hits the radius, it makes a 90-degree angle.
I definitely missed that.
Okay, also, RS and TS, tangents from the same circle, are going to be congruent right there.
So what kind of transverse RSQ then? A Q?
No, that's up to you. Okay, I basically just said the answer. When proving that tangent segments from an exterior point are congruent, oh, well, good thing this is, which theorem is used to show that those two triangles are the same? How do we know those two triangles are the same? I guess I'll draw really quick. You guys remember the theorems to prove triangles are the same, congruent?
Side angle side.
Yeah, those things.
Yeah.
Well, we know this is 90, that's what I just said, right? And this is 90. What else is the same in these two triangles? They share a side, that thing in the middle. What else has to be the same? Radii in the same circle have to be the same length. So by what theorem are these two triangles congruent? That's what they're asking. No.
They're not congruent.
Hypotenuse leg. Side angle was not one of them, remember, because it's like the bad word. But yeah, it's on right triangles you can use hypotenuse leg. So that's what they wanted for 11. Good thing that was not, 13. Find ST if QR is X. Yeah, I'm just gonna go back in that picture and start putting those in. QR is X. Now I put it in the wrong spot. RS is 2x minus 4. And QS is 2x plus 4. Whew, this one's a doozy. What's the relationship between these three things? No, that's angles. These are sides. Huh? Angles. Angles add up to 180. Sides could add up to anything. Just depends on how big the triangle is. But what do I know about what's the relationship between those three things? It's a right triangle.
Oh, so two of them are equal.
No, they're not equal.
Maybe.
Yeah. Leg squared plus leg squared equals hypotenuse squared. So this squared plus this squared equals that squared. X squared plus 2x minus 4 squared equals 2x plus 4 squared. Anyway, this is, how do I do 2x minus 4 squared? No. You have to do all of it times all of it. It's 2x minus 4 times 2x minus 4. So, what kind of problem is that?
It's foil.
Foil. So, the first is 2x times 2x. The outside is 2x times minus 4. The inside is minus 4 times 2x. You guys remember how to FOIL? The last is negative 4 times negative 4. So all this, and then what does this simplify to right here? Negative 8x minus 8x, negative 16x, right? So we have plus 4x squared minus 16x plus 16. I just moved it over. Okay, and guess what I'm supposed to do on the right side?
What?
Gosh, sure it doozy in here. Did I copy everything right? QR is X, RS, QS. Find S, yep. I wrote it right, unfortunately. Alright, 2x plus 4, same thing as this. FOIL. This time it has a plus though. Yeah, square. All of it times itself. Since it's two terms, you just gotta make sure everything multiplies. So it's 4x squared plus, it looks a lot like the last one, except for there's pluses where there were minuses. So it's 4x squared plus 16x plus 16. Alright, can I simplify anything else? What's x squared plus 4x squared? Okay, I mentioned this before, but how do we solve it when it's an x squared problem? Move everything to one side and factor. So I'm going to get rid of everything on this side. I missed the x right there. Yeah, it was kind of naughty of them. Maybe it's good algebra reviews, so next year you guys won't be like 2 years since you've seen stuff like this. Okay, 5x squared minus 4x squared is negative 16 minus 16. 16 minus 16 goes away, so it's all that, and then this side is gone, equals 0. How do I factor that? The first method we learned of factoring last year was take stuff out. What can I take out of both of these? X. What's left if I divide an x out of both of those? Oopsie. Okay, these two factors multiply to equal 0. So what x value do I need to use to make this equal to 0? 32. Or technically out here, if there was a 0 out here, a 0 would work. But x is the length of something, so does something being 0 long make sense? No, so it's just 32. Oh, geez.
It's not even the end of the problem.
Oops, not. That's what we have to plug back in. So the question was, what's ST? ST is going to be the same thing as RS. You guys see that in the picture? Oh, I lied. No, I didn't. ST is the same thing as SR. You guys see that in the picture? So we just got to plug it into SR, which was the 2x minus 4 thing. Jeez. 2 times 32, 64 minus 4. Well, they slid in a tricky one on me. So, yeah, the evens don't look near that hard, so you should be okay. Do you guys remember on 14, like, how do you draw externally tangent circles?
Yeah.
Looks kind of like this. So the question is how many common tangent lines you could draw? Like, you know, that kind of thing. Do you guys remember what internally tangent circles look like?
Yeah.
What?
It's the one inside the one on the
Yeah,
left still.
it's, they gotta be touching, tangent means they barely touch, but, yeah, it looks kinda like that. And then they ask again, how many common tangents there are. So tangents, remember, just touch at one point, it's gotta be on both circles, can't touch at 2 points. They are lines, they go forever. So it's just how many can be drawn. So 15 says, make a sketch illustrating each possible case of the total number of common tangent lines for two circles that are not tangent to each other. So these two circles are not tangent, they're not touching. How many tangents can be drawn?
Oh.
Yeah, kind of the top and the bottom and then the two diagonals. Let's see. Here's another picture where they're not tangent. How many common tangents do these two have?
0.
0. So this one had 4, this one had 0. What if I draw like this? How many common tangents do they have?
2.
Oh, you're correct. That's everything. I think, let's see, what would be a good stopping place? Maybe 22. It's over halfway. Yeah, I don't think tomorrow's gonna be quite as hard as today's. Nothing will be quite as hard as 13, I know that. Okay, 17. Find the measure specified for each described arc and its related sector or segment. Okay, find the circle's radius and the area of a sector defined by a 20-degree arc with a length of 3 pi. Goodness sakes. I'm kind of naughty on this one. All right. So it said the 20-degree arc. That'd be about like that. If the arc's 20, what's the central angle right here? They didn't really ask that, but the length of the arc is 3 pi. Find the circle's radius and area of sector defined by with the length of 3 pi centimeters. So the length of the arc is 3 pi. Okay, you guys will need this for 16. What's the arc length formula?
2 pi r equals sector area over 260.
Times theta over 360.
That's what I did.
That equals the arc length. Arc length formula. I'm not gonna make you memorize that. I'll probably just write it on the board and make you use it. Okay, so one of the things we're supposed to do is find the radius. So how do I do that? Well, just plug those numbers they gave us in the formula. What should I plug in for R? R. What should I plug in for theta? Yeah, that's the 20 degrees. What should I put in for the arc length? 3 pi. Okay, what's the algebra trick here? I'm trying to solve for r, so how do I get this guy by itself? Yeah, we can divide both sides by pi. 'Cause they're both multiplied, they would both be divided away. You could do divide by this, divide by that. What's 2 times 20 over 360 is 40 over 360 if we multiply those together. How do I solve this for r?
Use times 360.
Okay, yeah, you could do that, or how do I get rid of a multiplied value? So you can just divide by 40 over 360. You could also just divide it by 2 and divide by this. That would have worked. Should come out as 27.
Yep.
Then they also ask, what is the sector area? This was actually last chapter, sector area. Anybody think they remember that one? R squared pi. Remember that's the area of a circle? Okay, looks it up. And then you do that times the over 60. So it's 27 squared times pi times 20 over 360. Usually we didn't put pi in the calculator. So they probably didn't either. They probably put that in the decimal. Yeah, they put 2 answers. So you can do the fraction answer with the pi, or you can do the decimal answer. On 16, you can just do the arc length. The perimeter is like the arc length plus, it's the arc length plus 2 radius. But it's not that much more, but arc length. Really all we did this chapter was arc length. We didn't do sector area. Find the arc length sectors. Yeah, same thing on 18, you can just find the arc length. Everybody write the formula down?
Yep.
Okay, number 19. Yeah, we'll go to 22 on today. I probably better draw that. Oh, there is no center. Okay, looks like this, I think. No? Kind of. Connect that. Yep. Yep. C, W, X, Y, Z. Okay, arc WZ is 105. I got blue here. So this is more like yesterday's stuff, this page. Find the measurement of arc WXZ. WXZ. So that'd be all the way from here
So you 360 minus 105.
to there, yeah. So 105 is this arc, so the rest of the circle, together that'd make the whole circle, so they have to add up to 360. 360 minus 105. Well, actually, we kinda need to use that picture still, so.
This is a dream. Wake up. Wake up.
Okay, last one, 21. Measure of angle WXZ. WXZ, right here. Plus the measure of angle XYZ.
It's XWZ.
Oh, XW, which one, the first one?
Yeah.
XWZ, oh. Yeah, that makes more sense. XWZ and XYZ. Okay, we talked about this. I don't know if it's sunk in with anybody. Anybody have any ideas?
They're equal.
No. So, what kind of angle is this? Angle like XYZ right down here. Inscribed. So it should be half of its arc. Its arc would go all the way from there to there. The angle at the top, same thing. It's an inscribed angle, so it should be half of this arc. So together, they should be half of the whole circle.
So they equal 360.
No, they're half of the whole circle. Inscribed angles are half of their arcs.
But it's those two plus each other.
Right.
So
Together they make,
360.
no.
How the frick do they?
Inscribed angles equal half their arcs.
Yes,
The
but-
entire circle is 360.
But you're adding them together.
I know, but together they make three. Together they make the whole circle. But they're only half of their arcs. Oh, it's 180, yeah.
Okay. You didn't even say that at the beginning, though.
Yeah, anytime you have an inscribed quadrilateral, the opposite angles always add up to 180 because of that. That was the trick. Well, yeah, some of these were pretty hard, but I look like they're pretty much the odds. So you guys should have better luck on the evens.